The topic we are having today on physics is motion, under which we'll be treating motion of a uniformly accelerated body. Motion of a uniformly accelerated body. We shall have a look at using equations of motion, and as well velocity time graph. Now, today we are going to have a look, under this volume, we are going to have a look at equations of motion. Equations of motion. These are V equals U plus AT. S equals UT plus half AT squared. V squared equals U squared plus 2AS. These are the major three we shall be making use of under this topic. V is the final velocity, U initial velocity, A acceleration, T time, S is distance. Now, it should be noted that everything should have to be in a uniform unit, and the SI unit will be employed. So let's have a look at a question. This is an example question. A bus traveling at 60 km per hour accelerates uniformly at 5 meters per second square. Find its velocity after 2 minutes. All right. To answer a question like this, you need to analyze the question by writing out the information given, just to guide you, though it's not compulsory, but to guide you. A bus traveling at 60 km per hour, that is the speed with which the bus is traveling initially. Therefore, this shows that this is the initial velocity, which will be U. U is 60 km per hour, but I need to convert to meter per second. Why? Because our acceleration given here is a meter per second per square seconds. So we have to deal with the conversion first. When you are converting from kilometer per hour to meter per second, what do? You multiply by 10 over 36. 10 over 36. Let's see what that gives us. That's 16.7 approximately. So this will be 16.7 meters per second. Now we are given acceleration. We are given acceleration to be 5 meters per second square. A is 5 meters per second square. So we are asked to find its velocity. That means the velocity we are finding here should not be the final velocity, because since we have been given initial velocity. So V is what we are looking for, and we are given the time taken. Time is in 2 minutes. It has to be converted to seconds so that it will be uniform with others. So you multiply by what? 60. That's 120 seconds. Now, with this, we now have a look at which of the equations of motion is relevant. The relevant one is v squared equals to, v is equal to u plus at. That is the relevant one. Why is it the relevant one? Because we are finding v, we are given u, we are given acceleration, and we are given time. So that is the relevant one. So the applicable formula out of the 3 equations is this. So by substitution, u will be replaced with 16.7. Acceleration is 5 times 120. Let's do the calculation. That will be 16.7 plus 600. So that will be 616.7 meter per second. So that is the final velocity we are looking for. Let's have a look at another example. Now, this is another example. When the brakes are applied to a moving car traveling at 60 km per hour, so this is the initial velocity, the initial speed of the car, because this is what it's traveling with before the brakes are applied. So u is 60 km per hour. As we did in the previous example, we multiply by 10 over 36. This 10 over 36 is derived from 1000 over 3600. Please take note, because 60 kilometer is 1000 meters and an hour is 3600 seconds. So by the time you cut out the 2 zeros, the last 2 zeros, you arrive at 10 over 36. So take note of that. So this actually gives us, what did you get the other time? That's a 16.7. But when the brakes are applied, what happens? It decelerates. Please, decelerates. The word deceleration means negative acceleration. Negative acceleration in the sense that is bringing down the velocity from a higher to a lower speed. So let's take note of that. All right. Now, that means negative has to be assigned to this acceleration 5 meter per square second. So A will be minus 5 meter per square second because the negative shows deceleration or retardation. It could be any of the two words. Okay, find the time taken. We are looking for the time to reach a velocity of 36 km per hour. That means that's the final velocity now. The velocity with which it started was 60 km per hour. Now it's going down to 36 km per hour because brakes are applied. So V is 36 km per hour multiplied by 10 over 36 to convert. That will give us 10 meter per second. Now, having done this, we now think of the relevant equation of motion that is applicable to solving this problem. We are given U, we are given V, we are given A, and we are looking for T. Of course, the applicable one is V is equal to U plus AT because we have everything given, including what we are looking for. So by substitution, 10 will replace V. 16.7 will replace U plus open bracket A will now be minus 5 times time that we are looking for. So we have 10 equals 16.7 plus times minus is minus 5t. Now let's do a bit of mathematics here. So minus 5t will come here, become plus. 10 will come here, it become minus. I mean we have 5t equals to 16.7 minus 10. So 5t will be 6.7. You divide both sides by 5, being the coefficient of time we are looking for. So what does that give us? Let's check it out. That's 1.34. 1.34 seconds. So that is the time it will take for the velocity to drop from 60 km per hour to 36 km per hour. Another example. All right. In this question, we have a car moving with a velocity of 36 km per hour. This is the initial velocity, the starting velocity. So U is 36 km per hour. Multiply by what? 10 over 36 to convert to meter per second. That will be 10 meter per second. Accelerate uniformly at, the word accelerate means positive. So A is 10 meter per square seconds. For 30 seconds, the time taken to accelerate is 30 seconds. Find the distance covered. So we are asked to find S, which is the distance covered within this time. So what do? We look at the given information and think of the applicable equation of motion. The applicable equation of motion will be S equals ut plus half at squared. Why? We are looking for distance. We are given initial velocity u, which is here. We are given time, which is here. We are given acceleration, which is here. So that's why. So by substitution, S equals u is 10 times 30, which is time, half into bracket A, which is 10, times 30 squared, that is time given. So this will be 300 plus 1 over 2 into bracket, this will be 9,000. So S will be 300 plus, that will be 4,500. And what is the final answer? That's 4,800 meters. So that is the distance covered within 30 seconds, having accelerated at 10 meters per square second with a starting velocity of 10 meters per second.